Hello children, in this video I am going to give you the most important topics in each chapter. What is the minimum that you have to study from each chapter, and what you should know and what you should not skip to score at least 150 plus in the coming needs. I am also giving you the chapter wise weightage, expected questions, and how you should learn to get the minimum required marks. Okay, now see first units and measurements, and from units and measurements you should know how to find the units or the dimensional formula of a physical quantity. See, most commonly asked quantities are universal gravitation constant. What is the dimensional formula of universal gravitation constant? Then Planck's constant, Stephen's constant, thermal conductivity, and very rarely they ask self-inductance, then permittivity and permeability. Okay. Then one of the common question is finding the percentage error. Suppose a physical quantity x is given. This is an example, and x is given as a square b cube c raised to half d. And the percentage error in the measurement of A, B, C and D will be given, and you will have to find the percentage error in X. Okay, see how to find the percentage error in X, that is explained in our earlier videos. You can watch those videos. And the next thing you should know from this chapter is the significant figures. Okay, and now let us see the next chapter, motion in a straight line. And at least 2 questions, and sometimes up to 4 questions you can expect from this chapter. See, the main thing in this chapter is of course the equations of motion. V equal to u plus at, S equal to ut plus half at square, V square equal to u square plus 2as. You should know all these equations, and you should know how to apply and where to apply these equations. You have to keep in mind that, see, all these equations can be applied only when a body moves with a constant acceleration. And you can use these equations for uniform motion also. Means when a body moves with a constant velocity, provided you will have to put a equal to 0. And you cannot use these equations when a body is moving with an acceleration that is time dependent. Means the acceleration is not uniform. In addition to these basic 3 equations, you should know the equation for the displacement in nth seconds. That is S with the suffix n equals u plus a by 2 times 2n minus 1. And suppose a body starts from rest and moves with a constant acceleration. Then see the ratio of displacements in successive equal intervals of time. For example, for a freely falling body, ratio of displacement in first second, third second will be in the ratio 1:3:5. It's called Galileo's law of odd numbers. It is true not only for a freely falling body, it is true for any body which starts from rest and moves along any straight line with a constant acceleration. Then the ratio of displacements in successive equal intervals of time will be 1:3:5:7. Okay. And the most important thing is that the same concept you can use in the reverse order also. Means, see, instead of starting from rest and moving with the constant acceleration, suppose a body comes to rest with the uniform deceleration, then the ratio of displacements in successive equal intervals of time will be, see, 5:3:1 if there are 3 equal intervals. If there are only 2 intervals, then 3:1. If there are 4 intervals, then 7:5:3:1. Okay, body must be moving with the constant deceleration and it should come to rest finally. Okay, now see the next thing you should know from this chapter is analysis of graphs. See, in a one-dimensional motion, see, if you plot any graph, the first quantity is to be plotted along the y-axis and second along the x-axis. Velocity time graph means velocity along y-axis, time along x-axis. Velocity displacement graph means velocity along y-axis, displacement along x-axis. There will be two quantities that you will have to find out from a graph. The physical quantity represented by the area under the graph, that is equal to y into x, means quantity along the y-axis into quantity along the x-axis. The second thing that you have to find or determine from the graph will be the physical quantity represented by the slope of the graph. That is delta y over delta x. Delta y stands for the change in the quantity along the y-axis divided by change in the quantity along the x-axis. For example, suppose force is plotted against time. Then area under the graph will be force into time. That represents impulse or change in momentum. Now suppose momentum is plotted against time. Then the slope of the graph, that will be delta y by delta x, means change in momentum divided by change in time. That will give you the force acting on the body. Now see velocity time graph. Area under the velocity time graph represents displacement. Slope of the velocity time graph means delta y by delta x, means, see what is the quantity. Velocity time graph means velocity is the first quantity along the y-axis, time the second quantity along the x-axis. So slope is delta y over delta x, means change in velocity divided by time, that represents acceleration. In a similar manner, you can find the slope of any graph or the area under any graph. Okay, now see, let us go to the next chapter, motion in a plane. Means motion in a plane, you have to study these vectors, then projectile motion and uniform circular motion. See, in vectors, you should know how to find the magnitude of a vector if it is given in component form. Okay, then the dot products, applications of dot product, like work done equal to force dot displacement. So force vector and displacement vector will be given, or force vector and initial and final position vectors will be given in the component form. See, by simply finding the difference of final position vector and initial position vector, you will get the displacement vector. And how to find the dot product of two vectors if they are given in component form? You have to simply find the product of corresponding components of force and displacement. Means you have to find the product of x component of the force and x component of the displacement, y component of the force and y component of the displacement. Multiply these two, z component of the force and z component of the displacement. So you will get three products, and the sum of these three products will give you the dot product of the two vectors if they are given in component form. Okay, that you should know. And then suppose two vectors are given, and in the component form itself, see, one of the component is unknown, one of the component of one of the vectors. Okay, maybe see 2i plus 3j plus alpha k, that is one vector, say A, and the second vector is given 3i plus 4j plus 5k, like that. Suppose these two vectors are perpendicular, then what is the value of alpha? Okay, see, if two vectors are perpendicular, then their dot product will be 0. If two vectors are parallel, then their cross product will be 0. And if two vectors are parallel, then the ratio of the corresponding components will be same. Okay, see, if two vectors P and Q are parallel, then the x component of P divided by x component of Q will be equal to y component of P divided by y component of Q will be equal to z component of P will be divided by z component of Q, like that. Okay, now see, in projectiles, you should see the most commonly asked question is to find the range, initial velocity, and the angle of projection will be given. You will have to find the range. So or the time of flight or the greatest height. You should know the formula for the horizontal range, the time of flight, and the greatest height. Okay, and see the relation between them in any projectile. See, 8h equal to gt square equal to 2r tan theta. I have explained this in my videos. See, that is the relation connecting this horizontal range, time of flight, and the greatest height for any projectile. Okay, it's valid for any projectile. Okay, and the next thing you should keep in mind that when in case of a projectile, see at the highest point its vertical component of velocity is 0 and it has only the horizontal component, that is u cos theta, where theta is the angle of projection and angle of projection is the angle made by the initial velocity with the horizontal. These things you should know. And then the maximum range, of course, it is 45 degree, it is range is maximum when the body is projected at 45 degree. Okay, then in uniform circular motion, the you should know this one, v equal to omega cross r. V is along the tangent, omega is along the axis. Okay, these three are mutually perpendicular. Okay, velocity, omega, and the radius. Then see centripetal force mv square by r, that is also equal to mr omega square and m omega into v. These are the things that you should not skip from this chapter, motion in a plane. You can expect one or two questions from this also. Okay, see in any examination, see there will be 20% of the questions will be very simple, 60% of the questions will be moderate, and 20% questions will be slightly harder. See, from each chapter you need note, or you should not study each and every line. First you have to study the most important formulae, the most important equations, the most valuable concepts. Means there are some concepts that no one can skip, no one can avoid from the question paper. Such concepts, such formulae, such equations you have to learn first. Okay, now see from the laws of motion, chapter laws of motion, see F equal to ma you should know. It is the simplest formula that we have to study, and it is the most powerful formula. See, sometimes you can expect force is given, mass is also given, and you will have to find the acceleration. Okay, then see this is important, F delta t, impulse. Impulse equal to change in momentum. Okay, and see, suppose say cricket ball is being hit by a bat. Okay, bat exerts a force and the ball is in contact with the bat, see 4.25 seconds, like that. Then say we may have to find the change in linear momentum. Okay, and next thing, see this is the stopping time. Suppose a vehicle is moving with a linear momentum p, brakes are applied which provide a retarding force F. Okay, then the time in which the body comes to rest, it is called stopping time. Okay, now that stopping, see F equal to delta P by delta T, then delta T will be delta P by F. Okay, initial momentum is P, final momentum is 0. Okay, this is the change in momentum that is equal to the initial momentum, and this is the retarding force provided by the brakes. Okay, next most important formula from Newton's law of motion, that is when a body of mass m is kept on the floor of a lift and the lift moves up, then the force, then the apparent weight of the body is m into g plus a. See, apparent weight means that is the force exerted by the block on the floor of the lift. So that force is exerted by the block on the floor of the lift. To every action there will be an equal and opposite reaction. So if the block exerts that much force on the lift, then lift will exert an equal force on the block. So what would be the force exerted by the lift on the block? It will be m into g plus a in the upward direction. See, that is the force acting on the block. It is exerted by the floor, m into g plus a upwards when the lift is moving up. So the block also will be moving up. What are the forces acting on the block? M into g plus a upwards, mg downwards. So the force acting on the block upwards is more than the force it experiences in the downward direction. In the downward direction it has only mg. In the upward direction it has mg plus m into g plus a. So the resultant force is upwards. How much? M into g plus a minus mg. That is ma. That is why it is going up with an acceleration a. Okay, now when the lift is going down, then m into g minus a is the force with which the block presses on the floor of the lift. m into g minus a. See, that is then this block will experience an equal reaction exerted by the floor. So that reaction will be acting on the block in the upward direction. So what are the forces acting on the block? M into g minus a upwards, mg downwards, which is more. Mg downward force is more because in the upward direction it experiences only m into g minus a. So the resultant force will be downwards. How much? Mg minus m into g minus a, that is ma. That is why it is going down with an acceleration a. Okay, so anyway, the conclusion is m into g plus a is the force acting on the body in the upward direction when it accelerates upwards. M into g minus a is the force acting on the body in the upward direction when it accelerates downwards. Now see, this you can apply not only in the case of a body kept on the floor of a lift. You can apply this for any body moving in the vertical direction. Suppose a hot air balloon is moving up with an acceleration a. Then the force that acts on the balloon in the upward direction, that is usually the upthrust. It is m into g plus a when it accelerates upwards. If that hot air balloon is going down with a certain acceleration, then the upthrust acting on it is m into g minus a. Now suppose a fireman slips down along a rope. Then the force exerted by the man on the rope, it will be the same as the force exerted by the rope on the man. Okay, that will be m into g minus a when he slips down and m into g plus a when he climbs up along the rope. Now suppose a stone is being lowered by means of a string. Then the tension in the string is m into g minus a. And if that stone is being lifted by means of that string, then it is m into g plus a. Okay, so that is a beautiful concept. That is an important formula that you should not skip. Okay, now the next thing is friction. It acts tangential. It always opposes the relative motion. Okay, and the maximum value of the static frictional force is directly proportional to the normal reaction. The constant of proportionality here, it is the coefficient of static friction, and this is the expression for the maximum static frictional force, and it is called limiting friction. Now this is the expression for the acceleration of a body sliding down a rough plane inclined at an angle theta with the horizontal. Okay, now if the incline or the ramp is smooth, then what would be the acceleration? See, you will have to simply put this mu equal to 0. That will give you the acceleration down a smooth inclined plane. Okay, and the next thing, when a vehicle takes a turn of radius of curvature capital R on a level road, then this is the maximum safe speeds. Okay, that is equal to under root mu rg. See, you have to study this banging also, and the maximum speed that a vehicle can take on a banked road, that also it is there in the NCERT book, but this is that you have to expect for needs, or this is the most important topic from the circular motion. Okay, now let us see the work energy and power. Okay, see, in work energy and power, see, when a body is moving with a linear momentum p, then its kinetic energy k equal to p square by 2m. See, a light body and a heavy body have equal linear momentum. Which one will have more kinetic energy? Okay, that you have to use this formula. Or a light and a heavy body have equal kinetic energy. Which one has greater momentum? For that also you have to use this formula. Okay, now suppose a bullet is fired from a gun and the gun goes back, and it is called the recoil of gun. So the linear momentum of the bullet in the forward direction and linear momentum of the gun in the backward direction must be equal in magnitude, then only their resultant will become 0, because before firing the bullet was inside the gun and the gun was at rest. Total linear momentum was 0. Now during firing there are only internal forces, so the total linear momentum should remain as 0. Okay, so after firing bullets, that is a light particle, gun, that is a heavy body, these two bodies are of equal linear momentum. Which one will have more kinetic energy? See, this p square by 2 is same for both the bodies. Then mass is less for the bullet. So its kinetic energy will be more compared to the kinetic energy of the gun. Okay, in a similar manner, you will have to compare the kinetic energies of different bodies. And next thing, suppose a car and a truck are moving with the same kinetic energy. Car and truck moving with the same kinetic energy, brakes are applied, they provide equal retarding forces. Which one will come to rest in shorter distance? Okay, see, you have to use the work energy theorem. Work done equal to change in kinetic energy. Okay, see, from that you will get this. S is the stopping distance, means the distance covered by the vehicle before it comes to rest after the application of brakes. It's called stopping distance. And it is equal to kinetic energy divided by retarding force. Here car and truck, car is relatively lighter and the truck is relatively heavier. But both are moving with the same kinetic energy and the brakes provide equal retarding force. So both will come to rest in the same distance. Stopping distance is same for both the bodies. Okay, now see, force and displacement may be given and you will have to find the work done. Okay, force and displacement will be given in the component form. Okay, x component, y component and z component. Displacement also will be given in component form. You will have to find the work done, means the dot product of force and displacement. Okay, that is one question that you have to expect from work energy and power. And see, work done is the dot product of force and displacement only when the force is constant throughout the displacement. If the force is not constant throughout the displacement, there are two procedures, two methods to find the work done by a variable force. One is by integration, means you will have to find f dot dx. Okay, suppose a body is moving along the x-axis under the action of a force, say f equal to 2x square plus 5x plus 3. As it moves along the x-axis, its x coordinate will be varying and the force will vary accordingly. So it is moving under the effect of a variable force and you can find the work done as f dot dx. And also another procedure that also you have to expect many times it appeared in the Neet paper, that is force versus position graph will be given or force versus displacement graph will be given. You will have to find the work done. Okay, work done is the area under force displacement graph or it is the area under force position graph. Okay, and see the next you should know this one, work done equal to change in kinetic energy. It's the work energy theorem. And next, most important, that is the elastic potential energy stored in a spring, that is U equal to half kx square many times. Okay, see, we have seen in the past papers this application of this formula, half kx square, even last year. Okay, there was a question using this. See, the energy stored in the spring is capital U when it is stretched by 2 centimeter. What would be the energy stored in it if it is stretched by say 8 centimeter? Okay, and next this you should know the power, work done over time. Okay, and also the dot product of force and velocity. Then you should know the kilowatt hour, it is 3.6 into 10 raised to 6 joule, and horsepower, that is 746 watts. Then now see, from this work energy theorem you can expect see 2 questions mostly. Okay, next is system of particles and rotational motion. It is most of the students consider it as a tough chapter, but you have to expect only very simple questions. So you need not or you should not skip that chapter. You have to study only 2-3 things from that chapter. You will definitely get a question from that chapter and you can definitely do the question and you can definitely score from that chapter. Okay, what you have to learn? What is the minimum that you should know from this chapter? It is the center of mass. Okay, see, the position of the center of mass is given by m1 x1 plus m2 x2 divided by m1 plus m2. Okay. Then sometimes they will be given the positions of some point masses m1, m2, m3, etc. And their position coordinates also will be given. And you will have to find the x coordinate or y coordinate or both of the center of mass. See, x coordinate I have given you the formula. Similar formula you can use for the y coordinate also. Okay, or the y coordinate of the center of mass in case of a two particle system will be m1 y1 plus m2 y2 over m1 plus m2. Okay, next what is the what you should know other than this center of mass, what you should know next from the system of particles and rotational motion, it is the moment of inertia. See, it's analogous to mass in linear mechanics. Okay, and you should know the moment of inertia of some regular bodies. One is uniform rod, the second is ring. Okay, see the moment of inertia of a uniform rod about its central axis means it is if it is rotating about an axis passing through its center and perpendicular to its length, then its moment of inertia is ml square by 12. And see the moment of inertia of a ring, moment of inertia of a disc. Then see, I will tell you one thing. See, the moment of inertia of hollow bodies will be more compared to the moment of inertia of solid bodies. See, moment of inertia of ring and disc. Moment of inertia of one body is mr square and the other is mr square by 2. See, ring and disc. One is moment of inertia mr square and the other is mr square by 2. See, which one is larger value, mr square or mr square by 2? Mr square. That must be for the hollow body. Which one is hollow, ring or disc? That is ring. So the ring must be mr square and disc must be mr square by 2. If you put a large number of rings one over the other, what you will get? You will get a hollow cylinder. So the moment of inertia of a hollow cylinder is exactly same as the moment of inertia of a ring. That is mr square. If you put a large number of discs one over the other, what you will get? You will get a solid cylinder. The moment of inertia of a solid cylinder is exactly the same as the moment of inertia of a disc. That is mr square by 2. Okay, now see, you must know the moment of inertia of a solid sphere and hollow sphere. See, one is 2 by 3 mr square and the other is 2 by 5 mr square. 2 by 3 or 2 by 5? Which is more? Which is larger? That is 2 by 3. It must be for the hollow. So the moment of inertia of a hollow sphere is 2 by 3 mr square and the moment of inertia of a solid sphere is 2 by 5 mr square. See, these are the basic that you should know, that you cannot skip. See, from this definitely you will get a question and you can easily answer that question. Okay, now the next thing is rolling. Before that, see what is this? See, this k square by r square is very important. It is a ratio of a body that can roll. Rolling means it is the combination of rotational and translational motion. See, any rolling body will have a radius and the moment of inertia of that body will have mr square. See, the moment of inertia of ring is 1 mr square. The moment of inertia of disc is half mr square. See, please listen. In the expression for the moment of inertia, the coefficient of mr square is the ratio k square by r square. Let me repeat. In the expression for the moment of inertia of a rolling body, the coefficient of mr square, that is the ratio k square by r square. The reciprocal of that coefficient will be the ratio r square by k square. Okay, ring, moment of inertia is mr square. K square by r square is 1. Solid cylinder, moment of inertia is half mr square. So k square by r square is half. Spherical shell, or you call it as hollow sphere, the moment of inertia is 2 by 3 mr square. So k square by r square ratio equal to 2 by 3. I hope you understood. Okay, now see that k square by r square. You see, a rolling body means a body rotates and at the same time it moves translationally. So it possesses rotational kinetic energy and as well as the translational kinetic energy. See, E with the suffix E is translational kinetic energy, E with the suffix R is rotational kinetic energy, and E is the total kinetic energy. Okay, now see, rotational kinetic energy divided by translational kinetic energy equal to K square by R square. See, K is the radius of gyration and R is the usual common radius, simply radius. And this R square, that stands for, that corresponds to the translational kinetic energy, and K square corresponds to rotational kinetic energy. So rotational kinetic energy by translational kinetic energy, that ratio equal to K square by R square. Okay, now see, suppose a body rolls down a rough inclined plane, then its acceleration is g sine theta over 1 plus K square by R square. See, here also there is the ratio K square by R square. Now suppose a ring rolls down a rough plane inclined at 30 degree with the horizontal. Okay, so g sine 30 is 1 by 2. As it is a ring, K square by it is a ring, its moment of inertia is 1 mr square. So K square by R square is 1. So in the denominator 1 plus 1, that is 2. Okay, in the numerator g sine 30, that is g by 2. Divided by 2 means g by 4. So when a ring rolls down a rough plane inclined at an angle 30 degree with the horizontal, its linear acceleration is g by 4. See, once you get this acceleration, you can use any equation of motion like v equal to u plus at, s equal to ut plus half at square, v square equal to u square plus 2as. All these can be used for a rolling body. Okay. See, from this rolling, one question that you can expect is the acceleration of a rolling body over a rough inclined plane. And the second thing, where a body rolls, what fraction of its total energy is due to rotation? What fraction of its total energy is due to translation? Okay, and see, from that, see, you can find like this: A rotational divided by A translational, this is equal to K square divided by R square. Okay, and see, what fraction of its total energy is rotational, is due to rotational, means you have to find ER by ER plus ET. Okay, means you can use the component dividend rule that we have explained in our earlier videos. You can watch those videos. Okay. Okay, now we have the interesting chapter, that is gravitation. Okay, it is very simple, it is interesting, and most of you may be good in this chapter. You might be knowing all things, okay, because all the concepts, formulae, everything in this chapter are very simple. Okay, and first, the first thing that you should know is the expression for the acceleration due to gravity. Okay, on the surface of a planet. Okay, that is G equal to Gm over R square, where capital R is the radius of the planet and M is its mass. G is universal gravitation constant. And this universal gravitation constant, you can expect see its dimensional formula or units. Okay, and see the next, this 4 pi g rho r by 3, that is the expression for what? The acceleration due to gravity in terms of the density of the planet and its radius. Then variation of acceleration due to gravity with altitude, means height above the surface of earth, that you might be knowing, g with the suffix h equal to g into 1 minus 2h over r. And the variation of g with the suffix d means acceleration due to gravity with depth. Okay, that also you should know. Then this is the orbital velocity of a satellite in the minimum orbit. Minimum orbit means the orbit of a satellite around a given planet, okay, with the least possible radius. What? Orbit of minimum possible radius. It's called minimum orbit. And the speed of a satellite in the minimum orbit is the maximum speed with which a satellite can revolve around that planet. Okay, and it is V0, that is under root GR. It is also called first cosmic speeds. Okay, then see, this is the escape velocity. It is also called the second cosmic velocity. And from the surface of a planet, it is under root 2gr, where g is the acceleration due to gravity and r is the radius of the planet. Then next thing, this delta U, this is also an important formula. This will give you, see, this is the increase in potential energy. When a body of mass m is lifted from the surface of earth to a height h. Okay, suppose a body is lifted from the surface of earth to a height equal to the radius of earth. Then this h you have to replace by r. Okay, mgr in the numerator. And in the denominator it will be r by r, that is 1. 1 plus 1 will be 2. So when a body of mass m is lifted from the surface of earth to a height equal to the radius of earth, change in increase in potential energy will be mgr by 2. This formula you should know. Okay, when a body is projected from the surface of earth, after reaching the maximum height, it will come down if it is projected with a velocity less than the escape velocity. If it is projected with a velocity equal to or more than the escape velocity, it will never return. But if the velocity of projection is less than the escape velocity, it will definitely come back after reaching the maximum height. Now suppose a body is projected with k times the escape velocity, where k is less than 1. K times the escape velocity, where k is less than 1. Suppose k equal to half, or k equal to 2 by 5, or k equal to 1 by 3, like that. Then the maximum height attained is k square r over 1 minus k square. Okay, the next thing that you should know from the chapter gravitation is the Kepler's laws. Okay, and first thing, see, the planet will be moving with the constant aerial velocities, means equal areas and equal intervals of time. That is the first thing. The second thing, and maybe the most important thing, that is the square of the period of revolution of a planet is proportional to cube of the semi-major axis of its elliptical orbit. Okay, and see, you can definitely expect a question using this one, t square proportional to a cube. Okay, and see, from gravitation you can expect always 1 or 2 questions. Okay, now the second thing is mechanical properties of solids. You need to expect only 1 question from that, and the most important formula from that chapter is the energy density. It is half into stress into strain, the most beautiful formula. Okay, see this one, energy density, that small u represent energy per unit volume. Okay, and it is equal to half into stress into strain. And there is another formula for the energy density, that is half times Young's modulus, then small letter sigma square. That small sigma stands for strain. Okay, and see, capital U, this is capital U, and it is the energy stored in an elastic string or metal wire. That is Y Young's modulus, cross-sectional area A, X is the elongation, and L is the original length, Y ax square over 2L. Now the next thing is the bulk modulus. Bulk modulus is normal stress over see, volume strain. Okay, the negative sign is to show that when see, this normal stress is increased, volume will decrease. Okay, in this normal stress is nothing but the pressure. Okay, so delta P is the applied pressure, delta V is the change in volume, and B is the bulk modulus. The reciprocal of bulk modulus is called compressibility. Okay, and see, from this fluid statics, this is one thing that you should know. Okay, you should study. What is that? It is the hydraulic lift, or it is the application of Pascal's law. Okay, pressure applied to any point in a liquid at rest will be transmitted undiminished to everywhere in the liquids. Okay, so it is F by A, that is equal to capital F divided by capital A. Okay, the next thing that you should study is the laws of flotation. A floating body, in case of a floating body, mass of the floating body will be equal to the mass of liquid displaced. Okay, or weight of the floating body, you need not write weight of the floating body equal to weight of liquid displaced, because on both sides there will be g, and that g you can cancel. So finally it will be mass of the floating body equal to mass of liquid displaced. Okay, Now see from these properties of mechanical properties of fluids, most important, that is the surface tension. And see suppose n identical droplets, liquid droplets, okay, combine to form a big drop, okay, then its area decreases, then potential energy decreases. So that decrease in potential energy will be converted as heat. So when a number of droplets combine to form a big drop, there will be a slight increase in the temperature of the resulting drop, because decrease in potential energy will be converted as heat. Okay, and that decrease in potential energy, when n identical droplets combine to form a big drop of radius capital R, will be 4 pi r square n raised to 1 by 3 minus 1 into T. T is the surface tension. Usually 1000 droplets combine, or 125 droplets combine, or let us say 27 droplets combine, 8 droplets combine. Okay, this number will be usually a perfect cube, so that you can easily find this n raised to 1 by 3. If it is 1000, then n raised to 1 by 3 means 1000 raised to 1 by 3, it will be 10. If it is 125, it is 5 cube. 5 cube whole raised to 1 by 3 will be 5, like that. So this is the, let me repeat, this is the decrease in potential energy when n droplets combine to form a big drop of radius capital R. Or this is the work that you should do to split a drop of radius capital R into n identical droplets. This much work you will have to do. Okay, and second thing, see the energy of a bubble. It is 8 pi r square T. What is the question that you can expect? What is the work done? In increasing, or in to double the radius of a bubble, the work required to double the radius of a bubble. Okay, this is the energy, 8 pi r square T. Okay, when the radius is doubled, as this potential energy proportional to r square, when the radius is doubled, potential energy will become 4 times. Okay, initially u, finally it will be 4u. Then what is the work done? It is the change in energy. 4u minus u, that is 3u. Okay, u is 8 pi r square T. So 3u will be 24 pi r square T. That is the work required to double the radius of a bubble. The next thing, you should know the angle of contact. Okay, then angle of contact, when it will be acute, when it will be obtuse, like that. Then the capillarity. Okay, and next thing, most importance, that is the terminal velocity of a small sphere when it falls through a viscous medium. Okay, its terminal velocity is directly proportional to square of its radius, Vt, proportional to r square. See this Vt, terminal velocity, directly proportional to square of the radius. That you should not skip. That you can expect in any question paper. It appeared in Neet paper many times. So you should know. Suppose 8 raindrops combine in mid-air to form a single drop. Then what would be the final terminal velocity? See, when 8 droplets combine to form a resulting drop, the radius of the resulting drop will be twice the radius of the small droplets. Okay, so the terminal velocity will become 4 times. Okay, like that. See this terminal velocity, this you should know. It is actually you should know this Bernoulli's principle. Okay, and speed of efflux. Okay, see this is a tank. It is filled with a homogeneous liquid up to a height capital H. A hole is punched on the side wall at a depth small h below the free surface. Then liquid will come out of this hole with a velocity that is called the speed of efflux or velocity of efflux, V equal to root of 2gh. Okay, and that water jet strikes the ground at a horizontal distance x, and that x is equal to 2 under root small h into capital H minus h. See, we can have the, see in projectiles, we can have the same horizontal range for 2 different angles of projection. theta and 90 minus theta, or the sum of those two angles is 90. Like that, see, this x is the range here, okay, the horizontal distance traveled by this liquid jets, okay, and that x is the horizontal range. We can call it as range. We can have the same range for the liquid, or for the liquid jets coming out of two holes at depth h, small h, and capital H minus small h, just like theta and 90 minus theta. What stands for theta here? It is small h. What stands for 90 here? It is capital H. In case of projectiles, theta and 90 minus theta, same range. Here, small h and capital H minus small h, same range. Okay. In the case of projectiles, the sum of those two angles is 90. In case of this water jet, the sum of those two heights is capital H. Okay. And these are the things that you should not skip, or that you should learn from fluid mechanics. Okay. Now see thermal properties of matter. One question you can expect. See, you should know this conversion from one temperature scale to another. See, K minus 273 over 5. This is equal to C, Celsius reading, divided by 5, then F minus 32 by 9. And to convert see temperature in one scale to see corresponding value in another scale, then see suppose the temperature measured by a faulty thermometer is given, what would be its actual value? Okay, that also you should know. Then see thermometers used for specific use. For example, rapidly varying temperatures are measured by using thermoelectric thermometer. Then temperature near absolute zero is measured by magnetic thermometer. Then very high temperature like a temperature of the sun, temperature of the stars, temperature of electric furnaces, etc. are measured by radiation pyrometer. Such things regarding the thermometers you should know. Then these are the coefficients of thermal expansion, alpha, beta and gamma. Coefficient of linear expansion, superficial expansion and volume expansion. See during summer the pendulum will undergo expansion, so there will be some loss of time. This delta t is the change in the time period and t is the original time period, and this is equal to half into alpha, coefficient of linear expansion, and delta t is the change in temperature. Okay, small t represents time here and capital T represents temperature. Okay, this formula is very important. Then in thermodynamics, this is the first law of thermodynamics. It is very important. Delta Q, that is the heat added to a system. A part of it will be used to increase the internal energy, and the rest will be used for external work done. See, two quantities out of this will be given, and you will have to find the third unknown. Okay, then you should study this PV diagram, or called the indicator diagram. The area under the PV diagram represents work done. If that area is traced in the clockwise direction, work done is positive. If it is traced in the counterclockwise direction, then the work done is negative. Such things you should know. That is the work done. Then see, you should know Cp and Cv, molar specific heat capacity at constant pressure and specific heat capacity at constant volume. Okay, now see, when heat is added to a given quantity of gas at constant pressure, a part of it will be used to increase the internal energy and the rest will be used for external work done. What fraction of the heat added will be used to increase the internal energy? Suppose 1/3 of the heat is used to increase the internal energy, then 2/3 will be used for external work done. Suppose 40% of the heat added is used to increase the internal energy, then 60% will be used for external work done. Okay, that fraction or that percentage, that is very important. Many times it appeared in the Neet paper. Okay, now see, how do you find that? Delta U over delta Q. That is the fraction of heat added that is used to increase the internal energy, and it is equal to 1 by gamma, where gamma is the ratio of specific heats. It will be always greater than 1. What is gamma? It is actually Cp over Cv. Okay, now delta U by delta Q, it is 1 by gamma, then delta W by delta Q will be 1 minus 1 by gamma. Okay, now that gamma is given by 1 plus 2 by F, where F is the number of degrees of freedom. This number of degrees of freedom, if you know the number of degrees of freedom, you can find anything about the gas, okay, very easily. Okay, now what is that number of degrees of freedom? See, in normal temperature, at normal temperature for an ideal gas, we will consider only the rotational and translational degrees of freedom. See, we will consider the vibrational degrees of freedom only in very high temperature. Usually such questions involving or cases involving the vibrational degrees of freedom will not be asked. So you have to know only the translational and rotational degrees of freedom. It is 3 for monoatomic, 5 for diatomic number of degrees of freedom. Okay, it is 7 for polyatomic linear and 6 for polyatomic non-linear. Okay, see the translational and rotational degrees of freedom together. 3 for monatomic, 5 for diatomic, 7 for polyatomic linear, means the structure will be along a line, just like carbon dioxide. And 6 will be for polyatomic, means molecules containing more than 2 atoms. Non-linear means anything not along a line. Okay, the number of degrees of freedom will be 6. If you know the number of degrees of freedom, see, you know Cv will be F by 2R, where F is the number of degrees of freedom. Gamma will be 1 plus 2 by F, where F is the number of degrees of freedom. See, oxygen, you know that it is diatomic. Ammonia, you know that it is polyatomic and it is non-linear. Carbon dioxide, you know that it is polyatomic, it is linear. So you can find the number of degrees of freedom for any gas. If you know the number of degrees of freedom, you can find any quantity of that gas. Okay, now this gamma is 1 plus 2 by F, and fraction of heat added that will be used to increase the internal energy 1 by gamma. Okay, now you have to study. You should not skip the thermodynamic processes. There are 4 processes: isothermal, adiabatic, isobaric and isochoric. But the most important process, that is of course the isothermal, the process that takes place at constant temperature. And what is the equation that governs an isothermal process? It is the most beautiful formula, that is PV equal to constant. PV equal to constant. See, this isothermal process takes place at a particular temperature, at a constant temperature. And the work done in an isothermal process is W equals nRT. T is the temperature at which that process is going on. Okay. Then Ln, that stands for natural logarithm. Okay, V2 over V1, final volume divided by initial volume. As P1 V1 equals P2 V2, V2 by V1 will be equal to P1 by P2. So this equation we can write nRT log P1 over P2. Now after the isothermal process, what is the next important process? It is nothing but the adiabatic. See, in isothermal process, temperature is constant. Isobaric process, pressure is constant. Isochoric process, volume is constant. But in adiabatic, nothing is constant. Pressure varies, volume varies, temperature varies. But there will not be any exchange of heat between the system and the surroundings. You know, isothermal process should take place very slowly, and the system should have perfectly conducting walls in case of an isothermal process. But in adiabatic, the cases are exactly opposite. The system must have perfectly insulated walls. and the process should take place quickly. Okay, now see, pressure varies, temperature varies, and volume varies, but delta Q is 0, and the equation that governs adiabatic process is PV raised to gamma equal to constant, or it can be represented TV raised to gamma minus 1 constant, or T raised to gamma by P raised to gamma minus 1 constant. See, if you know this PV raised to gamma equal to constant, from that you can easily get these two. See, PV equal to nRT is true for any ideal gas under any condition. PV equal to nRT. Then PV by T equal to nR is true for any ideal gas under any condition. Okay, so adiabatic process PV raised to gamma constant, among these three, 1, 2, 3, among these three equations, the important equation that you should know is PV raised to gamma constant. Then TV raised to gamma minus 1 constant. Okay, and among these three equations, this is, see, this is very rarely you can expect. Okay, it is not that much common. Okay, now what is the work done? Work done delta W in an adiabatic process. See, this delta Q is delta U plus delta W, that is according to the law of conservation of energy, and it is the first law of thermodynamics. See, in this equation, if you put delta Q equal to 0, then what do you get? Delta W plus delta U equal to 0. Means delta W equal to minus delta U. Minus delta U. Okay, so in an adiabatic process, work done is negative of the change in internal energy. Okay, and that is P1 V1 minus P2 V2 divided by gamma minus 1. Okay. Now next thing, that is kinetic theory of gases. What you can expect from kinetic theory? See, 100%. This is the expression for the RMS velocity of gas molecules. And the most important thing, the RMS velocity of gas molecules directly proportional to the square root of absolute temperature, T. When the temperature is doubled, when the temperature is increased by 3 times, like that, you can expect a question. Or if the RMS velocity is doubled, what would be the final temperature? If the RMS velocity is made 3 times, what would be the final temperature? That is the question based on this formula. Okay, that is the most expected questions from question from kinetic theory. Okay. Okay, finally, see, oscillations, simple harmonic motion. See, what are the things that you should study or you should not skip from this chapter, oscillations? It is the basic equation of simple harmonic motion, A sin omega t plus phi. Okay, see, a general equation will be given, and you will have to find the frequency or the time period or the angular velocity or the amplitudes. Okay, if the equation is given, and you may have to find the velocity at a given time, or velocity at a given displacement, acceleration at a given time, or acceleration at a displacement. Okay, see, this is the variation of velocity with the position or displacement. This is the variation of acceleration with the displacement. Then maximum velocity omega a and maximum acceleration omega square a. Then time period t equal to 2 pi over acceleration for unit displacement. Acceleration for x equal to 1 means displacement equal to 1. Okay, this formula you should know. Then there are 2 examples of simple harmonic motion. The one is this one, 2 pi root of L by G. See, the period of a simple pendulum. Okay, then the period of a loaded spring, 2 pi root of M by K. See, when the mass is increased by 4 kilogram, then the time period increases from 2 seconds to 3 seconds. Then what was the original mass? Like that you can expect a question. Okay, and then see this simple pendulum also. Okay, then one thing you can expect, the superposition of linear SHMs. The most common example is, see, x equal to 3 sin omega t plus 4 cos omega t. X equal to 3 sin omega t plus 4 cos omega t. It is the superposition of 2 simple harmonic motions, 3 sin omega t and 4 cos omega t. Okay, now there is a phase difference between these 2 SHMs. 3 sin omega t, the other one is 4 cos omega t, means it is 4 sin omega t plus phi. Okay, what is that phi? Phi equal to pi by 2, because sin omega t plus pi by 2 is cos omega t. You may be asked to find the resultant amplitude. It is under root 3 square plus 4 square. Okay, it is under root 3 square plus 4 square. It is actually, see, in vectors, we find the resultant magnitude of two vectors under root p square plus q square plus 2pq cos theta. Similarly, when two simple harmonic motions along the same line are superimposed, the resultant amplitude you can find by using the same formula, that is under root a square plus b square plus 2ab cos phi. In the example that I have just told you, that is 3 sin omega t plus 4 cos omega t. 3 sin omega t, the second is 4 cos omega t, means 4 sin omega t plus pi by 2. So, for the first simple harmonic motion, it is only sin omega t, means omega t is the phase. For the second simple harmonic motion, it is 4 sin omega t plus pi by 2. So, omega t plus pi by 2 is the phase. So, the difference is pi by 2. It is just like the angle between two vectors. Here the phase difference between two simple harmonic motions. Then the resultant amplitude is a square plus b square plus 2ab cos phi under root, where a and b are the amplitudes of the individual simple harmonic motions. Okay, that also see we can expect. Then the energy of a body executing simple harmonic motion: kinetic energy, potential energy, and total energy. What fraction of its total energy is due to kinetic? What fraction of its total energy is potential? See, potential energy by kinetic energy, that is, potential energy by total energy, that is x by u whole square. If 1/3 is potential, 2/3 will be kinetic. How do you get that? 1 minus 1 by 3. So, x by a square is the fraction that is due to potential energy. Then, kinetic energy will be 1 minus x by a whole square. Okay? Okay, next is wave motion. See, in this chapter also, you should know the general equation of a plane progressive wave. Okay, from that equation, you may have to find, see the velocity of the wave, amplitude, then time period, frequency, angular frequency, okay, wavelength. Okay, now wave propagates with a constant velocity. It's called phase velocity. And it is v equal to omega over k. K is called a propagation constant. When a wave is propagating through a medium, particles of the medium will be executing simple harmonic motion. So there are two motions. One is wave motion and the other one is particle motion associated with the wave. That particle velocity is not constant. Its maximum velocity is maximum particle velocity, it is omega a. And wave velocity is constant, it is omega by k. The ratio of maximum particle velocity to wave velocity is very important, and it is equal to Ka. Okay, and then you should study the standing waves: open pipe, closed pipe, and string. See, one question from this standing wave is 100%. Definitely you can find a question from this topic, and anyone can easily answer. Only thing, see, you should study the fundamental frequency and the ratio of the possible frequencies in case of open pipe, closed pipe, and string. Okay, the next thing, see, n correction, sometimes very rarely n correction, but it is very simple. Okay, now tuning fork. When two sources of slightly different frequencies are sounded together, beats will be produced. And beat frequency is equal to the difference in frequencies of the two sources. Okay, that beat frequency you have to study. Then the most important thing, that is the Doppler effects. Okay, the apparent frequency of a source due to the relative motion between the source and the listener. See, you need not study the formula for each and every case. There is only one formula for all the cases. Okay, so if you know one formula, that is very simple. If you know that formula, you can solve any question easily. That formula See, nu dash equal to V minus VL divided by V minus Vs into nu. Nu is the actual frequency and nu dash is the apparent frequency. Okay, V without suffix is the velocity of sound, velocity of the wave. Okay, and Vs is the velocity of the source and VL is the velocity of the listener. See, there is no negative, see, there is no plus sign. See, in the numerator it is V minus VL, in the denominator also it is V minus Vs, no plus. Both the terms are minus. Okay. Now you have to follow a sign convention here. If you follow that sign convention, everything is very simple. You need not remember anything actually. What is that sign convention? See, you can draw the source anywhere. You can draw the listener anywhere. What would be the direction of propagation of the sound? It will be definitely from source to listener. See, all the velocities along the direction of propagation of the sound are to be taken as positive, opposite direction negative. That is the only sign convention you have to follow here. Okay, then you see, you can never make a mistake. Okay, whatever you do, it will be right only. Okay, only thing is that you have to follow this sign convention. Okay, see, the same or similar convention we follow in optics also. Direction of propagation of light is to be taken as positive. All the distances measured in that direction positive, opposite negative. Okay, so you have to know only this formula to solve any question in Doppler effect. So all the important concepts, formulae and expected questions I have explained from the topics of class 11. Okay. See, from class 12 topics I will explain you in another video, and thank you for watching.